Welcome back to 8.6 Natural Logarithms. This is the second objective of this section, solving equations using natural logarithms. Okay, our first example is example 3, and we're going to be solving this. We're going to be using the knowledge that the ln is the inverse operation of the e to the x. So let's go ahead and do that. Right. Now, when you see this, and it just says solve ln of 2x minus 4 cubed equals 6, I want you to think e, right? So think e. This is going to be e. We're going to raise both of these to the e. We're going to take the exponential one. Oh, just ignore me. Okay, now e and ln, natural log, these are inverse operations, so they cancel each other out. That's why we did it. 2x minus 4 cubed equals e to the 6. But we just have to put that e to the 6 in the calculator, and that's where I would start anyway. Second function, e to the x, e raised to the 6th power, close, and that gives us 403.43. And now we have this 2x minus 4 cubed. We're going to take the cube root of both sides. And I guess we could have done that here, but anyway. Okay, so that cancels those out, and now we have 2x minus 4 equals remember the math. We have to find the cubic root in the math down here. It's number 4. We have, I'm actually going to go and do second answer because that's going to put the last answer we had in for this, and that's what that is. So now that gives us 7.39. 7.39. Now solving this for x, we're going to add 4 to both sides. Wow. 2x is 11.39, and divide both sides by 2. And that is going to give us 5.7 something. My brain is not wanting to function. Not as quickly as I want it to. 5.695. Which is approximately 5.7. Okay, so that would be your answer. Hopefully that helps. All right, so again, if you see solve natural log, you think e, raise the e to both of them so that you can, the inverse operation of the natural log is e, and that's why we do that. Okay, next example, solving an exponential equation. All right, well, just like e is the inverse of ln, ln is the inverse of e. The first thing we want to do here is get that term with the e by itself, excuse me, and then get the e completely isolated, the e and its exponent. Take the natural log of both sides. That cancels out, and then you just use your calculator. Okay. So over here, we have 4e to 3x plus 1.2 equals 14. So we want to subtract 1.2 from both sides. That cancels. We have 4e to the 3x is equal to 12.8. Now we need to divide both sides by 4, and that cancels those out. We have e to 3x equals 3.2. Now, to get to that x, we're going to have to do the inverse operation of that e. So we're going to take the natural log of both sides. These cancel, and this leaves us with 3x equals natural log of 3.2. Divide both sides by 3, and we have our final answer. Let's go ahead and take a look at the calculator. And move this guy over. So we have natural log of 3.2. You'll notice that it automatically opened parentheses, so you want to close those. Divide by 3 and hit enter. 0.3877, so 0.39. Okay. So we have 0.39. And that's it. Okay. All right, final example, example 5. This is a PERT problem, and it's called PERT because of this principal times E, rate, and time. You saw these back in Algebra 1, Chapter 8. I don't know if you remember it or not, but you have hopefully seen these before. But that was also right before the EOC, so your brain may have been completely fried. Okay, a few things here that we need to note with respect to this formula. A is the amount of money that's in the bank. This is only for continuously compounded interests. So this is the continuously compounded interest formula. The P is the principal, what you put into the bank to begin with. E is just E. R is the rate per year. So whatever the rate, the interest rate is per compound. So, but it is, you take it, if it was compounded semi-annually, then you would do 0.08 divided by 2. That would give you 0.04 for each time, because that's an annual interest rate usually. And then the T is normally the question. Okay. All right, let's go ahead and take a look at this. An initial investment of $200 is now valued at $254.25. So we've got A equals PERT. This is my P, the initial investment. This is my A, the amount I have now. The interest rate is 6%, and I need to write that as a decimal, and that's compounded continuously, so that's how we know we're using this formula. That's going to be 0.06, which is the R. How long has the money been invested? So now we just plug everything in. 254.25 equals 200E 0.06T. Well, I'm going to divide both sides by 200 to get rid of this. That will leave us with, oh, where'd it go? $254.25 divided by 200 is 1.27. So you got 1.27. And that was the part that was throwing me off. All right, now this equals E raised to 0.06T. Well, we have that E. We need to get rid of this to get to the exponent. So the inverse operation is the ln, natural log. So going down here, the natural log of, I'm going to do answer just like we did before. That's going to give us 0.24. And I'm just going to write that down. So we got 0.24 equals 0.06T. Divide both sides by 0.06, and obviously you move those over 2 places, so T is 4. So it has been invested for 4 years. So $54.25 that you've done nothing to earn except put money in the bank, not a bad deal. All right, that concludes this particular assignment and this objective. So any questions, please feel free to let me know.